Good morning or good afternoon, everyone. Thank you for joining us today for securing your infrastructure before, during, and after deployment. We have three great experts today from Snyk, CircleCI, and Pulumi. And if you're here today joining us, you're obviously aware of the trend of infrastructure as code. With it comes the rise of cloud computing and the popularity of technologies such as open source Kubernetes and containers. So the developer is more in control of the application stack than ever before, but there are new security risks and the risk profile has changed. So we're going to hear today from Tomas Gonzalez of Snyk, Angel Rivera of CircleCI, and Paul Stack of Pulumi, talking about these complex environments that are dynamic with applications assembled with both your custom code and open source components. When security can be addressed early on and become a natural part of the workflow, there is a way to handle these misconfigurations. And that's what our experts are going to talk about, as well as demo. We are going to take questions at the end, so please feel free to use the chat window on the side and we will, for comments or any questions, and we'll get to them at the end. So with that, I'm going to kick things off with Angel. So take it away, Angel.
Thank you, Sarah, and welcome everyone to this webinar. I'm excited to get into talking about infrastructure as code, securing that, and also how you can integrate all that functionality into pipelines, as well as testing your deployments post execution. So let's go ahead and look at the agenda real quick. I'm going to jump in real quickly to talk about continuous delivery, specifically with CircleCI. Then we're going to jump into some security scanning with using the Snyk client and tool, and also in regards to the Snyk orb. Then we're going to move into talking about cloud engineering with Paul. Then we're going to demo a few concepts using all the tools that we're going to discuss today. And hopefully we'll have a great question and answer session with all of you. So let me talk about continuous delivery. And I'm going to talk to continuous delivery as a concept and practice, and then move into how CircleCI kind of facilitates those practices and principles. So real quick, right? Continuous delivery, I'm sure you've heard this day in, day out. Some people have different definitions of it. I've heard, even myself for a while had a different definition until I actually looked at how all of continuous delivery really, is defined and implemented. But basically, continuous delivery is a practice of basically building your code, testing, doing all the things and processes that you need to do to your code using automation, right? So as developers, we build code usually locally on some laptop or a server that we use as a development environment. Then we do a lot of manual things like testing. We do a lot of manual things like, running linters. We do a lot of manual things is the point here. And when you're using continuous delivery, you can still accomplish those, the things that you're doing manually, but you want to do that using automation, right? And that provides consistency as well as a higher velocity. So when you're talking about continuous delivery, you're usually talking about a pipeline. And basically a pipeline is an overall kind of aggregation of all the things you're executing using automation in a controlled manner. So that means, you write some code, you commit it to your version control system, and then that's when your pipeline starts kicking off, right? And you can do things like automated testing. You can do things like scanning for vulnerabilities using tools like Snyk. You can build your Docker images or artifacts that you need. Then you could deploy those things right into whatever target environment using tools like Pulumi and infrastructure as code to assist in that automation. So continuous delivery is basically like I would say in the hierarchy is a parent to continuous integration and continuous deployments. So a lot of folks get this confused. The CD in CI/CD is continuous deployment. I actually used to say continuous delivery deployment, try to be, keep things concise and meaningful. But the reality is the CD and CI/CD stands for continuous deployment. And to dispel any of those kind of patterns that are out there that are not really, I would say they're not accurate. Again, continuous deployment is referenced as CD in CI/CD. Now let's talk about continuous integration. For those of you that don't know, right, it's the practice of merging your work and your individual teammates' work into a shared code repository. And the reason you would do that is it will increase the communication and collaboration around the code that you're working on and the code that your other teammates are working on. And you can kind of suss out any issues, right? Head them off at the pass before even committing them to branches. Another benefit or process within continuous integration is developers are merging code changes often, right? So we're working on smaller chunks of tasks, and then we're completing them and then testing them, right, in the system, or at least merging them into code bases so that, number one, we can control the work that we're doing a little bit better, and instead of merging huge commits and changes, and that could really confuse things at some point. We're doing it in smaller chunks, which actually gives us a little bit of focus on what we're doing. And then, of course, right, we're going to run our automated tests to validate the builds. The other benefit is only tested code, right, is integrated into the code base. So that gives you a nice layer of consistency, quality as well. And then finally, the biggest and my most favorite benefit of continuous integration is the continuous feedback loop, right? And what I mean by that is, right, as long as we're pushing our code and small changes and we're doing it often, we're able to detect when things are bad, right, in our code. When we have issues, and it's quickly identified, we can do a quick fix and then push that fix up and, right, wait for that results of the pipeline to come back to us. So that's what that continuous feedback loop means, is always checking your code, making sure that it fits with all of your test conditions and they're passing. So continuous deployment, right? It's the practice of just deploying all of those things you did in your CI portion, right? So we're packaging up this release into whatever artifact you need to deploy. And then you're actually, right, deploying that to target environments using automation. So here's some of the benefits, right? You're doing faster release cycles. You're doing on-demand releases, which means, like, you're going to build a release, and then depending on how your pipelines are configured, you could actually just deploy it to your production environments because you're super confident in those builds. Some companies do that right off the bat. Some don't, but it's up to the organization. And obviously, right, you're going to have higher quality releases because you're running tests, you're doing all the things that you need to do, scans, right, whatever it is that you have in your process to do, they're being done automatically, and that increases the confidence of that release. And finally, again, right, the continuous feedback loop on those deployments. So if you deploy the application to your target environment, you can run some sort of test, which we're going to show in our demo, right, to make sure that the application is at least running and functioning in that target environment that you've deployed to. So what I just described are just practices and principles. And these are things that teams need to kind of define amongst themselves and then adopt and implement. And it's really hard to do. It's more of a cultural thing, right? But once you have that down, you're going to have to accomplish this using automation, right? So now that you have your CI/CD practices and principles in place and everybody's agreed to them and everybody's functioning and operating and developing in that manner, you're going to have to make those practices and principles and processes become reality. And that's where automation comes in, as well as CI/CD tooling. And basically, that's what CircleCI is. We are a CI/CD platform, right? And the mission is to get your code, from idea to delivery as easy as possible. And this company was founded in 2011. We're definitely over 280 employees. The cool thing about CircleCI is we re-architected the platform a couple years ago, and we launched version 2.0, which added a ton of new functionality that was needed, and it brought us into kind of the modern day age of CI/CD platforms and computing. And one of the other interesting things is we build 1 million plus source code or jobs per day, right, on the platform. So that's a lot, right, of code. That's a lot of processing that we do for our clients or customers in the community. So that's a pretty impressive number, and it shows that a lot of folks trust CircleCI to basically execute their very critical processes in their software development life cycles. So here's a nice diagram I like to show about how continuous delivery sits in the middle, right, as a practice and principle, as I spoke to earlier. And then, you have your kind of CI components of this process in the blue. Then you have CircleCI sitting in the middle, automating all of those things, right? And of course, we definitely need a runtime, right, to execute on. But again, it's just a nice little circle and iteration of how things occur from, again, practices and principles, and then leveraging a CI/CD tool like CircleCI to complete all of your continuous delivery processes. Here's another nice diagram where we're showing where CircleCI kind of sits in your tool chain and in your processes. Obviously, right, if you're looking to the left, we're in the creation zone there. You're talking about collaboration, where your code lives, making changes to all those things, right? And then you're committing that. Once you commit it, CircleCI detects those changes, then we run your delivery pipeline, right? And that's defined in a config.yaml file, which I'll get into in a minute. And then finally, right, if you have some sort of deployment to any kind of target environment, then we execute that for you and ensure that your application is released to the target environments. So here's some concepts within CircleCI, right? So we're a CI/CD tool. We have these terms and elements within the pipeline, which number one we call pipelines. So pipelines are the overall execution of a delivery pipeline, so to speak, right? And within that, we have this concept of jobs and workflows, which I'll get into in a minute. We also have concepts of executors, the config.yaml file, which is basically where you define your pipeline. And then we have some special commands, and where you also have the ability to debug in the platform. So let's talk about pipelines. Again, we're just encompassing the full set of workflows within your configuration. All right, and what that does is just basically triggers jobs and steps. And jobs are just a collection of steps, which are another collection of commands that you're going to run, right? So these are things like, you're running AWS commands, or you're running a Snyk command to scan software, which I'll show you a little bit later in the presentation. Then we're talking about workflows. So workflows just orchestrate all of the things, all of the jobs, I should say, that you have, created in your configuration file, and it just basically again kicks off those jobs in the order that you desire. And you can also do things concurrently, sequentially, if you need to kind of build some dependencies on other jobs accomplishing. And then we also have things like in a manual approval job setting, which we're going to show examples of that as well. And of course, right, so when you're deploying things or running things, you have to run them in a runtime. And these are the ones that we support. Currently, it's Docker. AWS, we give you a full virtual machine to do your work in. You could use a Microsoft runtime as well. And we also offer Apple iOS, macOS iOS. So the config.yaml, again, is the definition of the entire pipeline. So we do everything as configuration as code, which is considered, kind of on the same lines as infrastructure as code, but for your CI/CD pipeline. And one of the other things I wanted to mention here is with the upgrades that we did to the platform 2.0 and 2.1 on CircleCI, we've introduced the ability to create parameterized YAML, which I'm going to get into in a moment, but that gives you the ability to reuse a lot of the functionality that you have in your CI/CD pipeline config. So finally, I wanted to mention that, right, if you have to, you can also debug failed jobs using SSH. So what happens is if you have an issue with one of your builds, you can rerun that build and tell the system to leave that runtime available so that you can SSH into the failed environment and then debug all of the things that are happening right within your build. It's a really nice tool that not a lot of CI/CD tools have. Aside from CircleCI, there's like very few. But this is a great way to kind of help the developer debug their applications without bothering, or not bothering, but like, having to stop and wait for other people, maybe other teammates or folks in the operations team to help them. They can just do it, right? Like self-serve, which is really, really nice for keeping things, again, developing the software faster, also debugging software faster, and then executing your CI/CD pipelines so that they pass, and you can move on to the next task in your sprint list. So I wanted to talk about orbs real quick. So I mentioned that we implemented a parameterized YAML. Orbs is a way to kind of take that reusability of that parameterized YAML and package it up into a nice, clean, shareable piece of configuration. And it's really simple, right? So what we've done is we've kind of created a DSL, so to speak, a domain-specific language within CircleCI's platform. And those things are consistent of commands, executors, and jobs, which are the main things that are main elements within CircleCI's platform, right? So you need an executor to actually kick off a job, which then kicks off the commands that you want. By parameterizing values within these elements, you're able to, again, get a nice reuse of code, encapsulate functionality, and then be able to kind of share that information with everyone who I guess you allow to do it. We have actually all of the orbs right now are pretty much open sourced. But that also lends us to have, or gives us the ability to have vendors and partners such as Snyk and Pulumi. It gives them the ability to package up their functionality, right, and their products into a nice, clean, easily implementable package within their config.yaml. We at CircleCI, again, we're an automation platform, so we basically run a lot of other companies and partners, or our customers run a lot of our partners and other companies tooling on our automation. So it just made sense to kind of bring them all together and enable them to build out orbs so that their products can be easily implemented into CI/CD pipelines. Again, like we're having this webinar with our partners Snyk and Pulumi. So they've already built orbs, which are pretty cool, and I can implement all that functionality. So without further ado, I'm going to go ahead and jump over to my colleague here, Tomas Gonzalez from Snyk, and he's going to talk a little bit about Snyk.
Absolutely. Thank you for that introduction, Angel. There is a growing trend in organizations adopting continuous integration, continuous delivery, and continuous deployment. And that is why I preface this Snyk section with continuous security, which has become a growing need as organizations look to adopt this automation and these pipelines for delivering their software. Security can no longer really be introduced at one stage in the pipeline. It needs to be present throughout. So I'm going to talk about continuous security within this section. So for those that haven't heard about Snyk, a little bit about us, we have been around for about 5 years, and our mission is to help companies and developers develop fast and stay secure. We have a vibrant community of over 1.5 million developers. We have 350 plus employees and still growing. So we're definitely here to help. And we've built these, we do this by responding to the change in paradigm that your continuous delivery methodologies and continuous deployment have really introduced. So if we look at this chart, let's call this the pre-cloud era. Before things shifted to cloud, there was a very clear delineation between what the developer was responsible for in the applications they were building and what IT was responsible for. Developers had to secure their code, make sure their open source libraries were up to date and secure, and then IT provided them this sort of base image or golden image, if you will, where the application was going to be run in a production setting. Fast forward to how this has changed in the cloud. And developers now are not only responsible for the code of their applications and the open source packages, but also they're packaging these apps into containers. They're defining the infrastructure where these applications will run as code. And all of this is facilitated by DevOps services and pipelines such as CircleCI. So what does this mean? Net, it means that the more software that we're putting into developers' hands, there's more risk that they're responsible for. So if we think about this in the form of an iceberg, the tip of the iceberg, what's floating above the ocean, this is what developers have direct influence over. It's their custom code. It's the code that they write. But in a modern application, they're not writing the entirety of the application stack. Most of what they're doing is assembling together a lot of open source components. So with this, we start to get under what's under the ocean. What don't developers have visibility into? We've done studies, Snyk has and other companies have, around the composition of code bases, and Snyk has, through our research and other industry reports will agree, the majority of code of a modern application's code base is open source. And because of the majority of the code base is open source, it's safe to say that the majority of the risk associated with that code base is introduced by those open source components. Now, augmenting this even further, these applications are getting packaged into containers, make them portable, make them easier to scale. And those containers are also going to have open source in the majority of cases, typically in the form of Linux packages. So they bring about a lot of good, but they also introduce a lot of risk. And then finally, at the bottom of that iceberg, how those applications are going to be run and deployed in a production setting lies the infrastructure as code, which the number one issue for IAC, which I'm not going to steal all of Paul's thunder for this, but it's misconfiguration of those infrastructure as code templates. So, similar to the graphic that we saw before, this is how developers are now responsible for defining the machines that their applications are going to run on, how those machines talk to each other, the firewall rules, the network rules, and so on. Everything that the IT typically was responsible for before. So digging into the risks specifically that are introduced, let's start with open source. We've already stated that the majority of an application's code base is open source. So what does this mean? Think about it in terms of dependencies. I have this application that I wrote. It consists of 3 files, 80 lines of code, and I am declaring in this application that I want to use open source dependencies. And what I need to remember is that if I declare a certain number of dependencies, I declared 7 dependencies in this application. Those dependencies also have dependencies. So by declaring 7 dependencies, I'm really introducing into my code base 59 additional dependencies on top of those 7. So now my 80 lines of code suddenly turn into 713,000 lines of code, right? This is all code that the developer did not write. But they're still responsible for the security of that. So making sure that the open source used in the code base is secure, that's one way to ensure that you're not introducing risk into your applications when you're leveraging the benefits of open source. Second, touching on the containers, it's very hard to imagine DevOps and cloud without containers. Reports from Gartner and other organizations have seen an increasing trend that containers used in production are growing. And we have actually at Snyk done research on the most popular Docker Hub images. And we have found that the top 10 most popular images in Docker Hub, they contain vulnerabilities. And extending that to the top 1,000 images available in Docker Hub, over 76% of those also have vulnerabilities. So it's really important for developers to know what exactly they're introducing into the code base when they pick what container images they want to build their application on top of. And then finally, for the infrastructure as code portion, so this is another growing trend, and there's many implementations of this. And again, I'm not going to steal Paul's thunder with this, but we see these templates that define how the infrastructure can be spun up, created on the fly for deploying applications, and then tore down We see many people contributing these templates back to the open source community through their GitHub repositories. And there's various different infrastructure as code providers. But again, similar to how I mentioned earlier, the risk is there that you forget something that opens up a potential security hole in your IAC templates. So these could be exposed ports. These could be not specifying the permissions that your container images have running as root. The list of misconfigurations could go on. So it's important to check those infrastructure as code templates as part of your pipeline to ensure that you're not going to be exposing a risk through the way you deploy your applications. And so these three areas of risk are what Snyk is responding to. We have built what's called the Cloud Native Application Security Platform. It has three primary components: the Snyk open source for managing the open source risks, Snyk container, and then Snyk infrastructure as code. These are built upon our core beliefs that these capabilities should be delivered to the developer and empowering that developer to make the decisions and have that autonomy to choose how they respond to the risks introduced. Make it easy to plug into the SDLC and augment all the information that we're exposing around those risks with deep security expertise and context so the developer knows what change they have to make and where. So visualizing this in the concept of a pipeline, we see continuous delivery right there in the center, but Snyk really has a role before and after as well. In today's demonstration, we're mostly going to see that continuous delivery portion, but it is important to introduce testing across the entire software development lifecycle. We'll dig a little bit into this during the demonstration to show you what that's like. So to recap what we're doing different and what we're going to see in the demonstration today, we're going to see how Snyk exposes information that empowers developers so that they know what issues are present in the way they're architecting their applications and how to fix them. We're going to show how Snyk provides remediation guidance to help developers spend less time triaging vulnerabilities and more time integrating and testing. And I'm going to show you a little bit about how we power all these insights through our dedicated knowledge base called the Snyk Intel. So more to come on the demonstration, but before that, I'm going to now hand it over to Paul, who will talk about the infrastructure as code component and its implications when actually applying those templates and putting them to work. So Paul, over to you.
Hey everyone, so thank you so much for having me. It's really good actually to be able to tie a lot of these concepts together, and something that we have been professing a lot inside Pulumi itself. And we like to think of ourselves as much more as modern infrastructure as code, because we try and bring all these different pieces together, the testing, the pipelines, the ability to really bring software practices into what people are doing. So it's really great to be able to work quite closely with partners to deliver a webinar on this. So it's really important to understand, I'm taking a step back before I go into what we're doing here. It's really important to understand that we are on a cloud journey, and how IT is moving and how operations and how teams are moving is changing. Now, it's not just due to current events like COVID-19 and lots of different things that has accelerated it, but there are lots of different variations of what people are actually doing and moving into the cloud. So you have some people who have effectively picked up their traditional data center, which is mostly end-tier style architecture, and just pushed it into the cloud. It's very static. They have some web servers, some database servers. They're probably a little long-lived, and they're probably not really destroyed, or they're more manually managed to keep what's happening there. And then you have people who have gone at it from a slightly different angle, who have a much more transitional style approach. They're maybe experimenting with a mix of containers and virtual machines, and definitely bringing in some types of tooling like SaaS-based products that they can start to understand what's going on in their environment. And it's very much a much more fluid style system that people actually have to manage. And then you have people where we're going into this cloud native style architecture, this new wave sort of microservices based. Everything is very dynamic, very fluid. You're definitely taking advantage of probably a container hypervisor, something like Kubernetes, maybe HashiCorp Nomad, Docker Swarm, lots of different things in there. And you never really get a static environment. Everything it needs to be built on the fly. You can't really run a lot of it in your machine, and it would be almost impossible to manage this manually. Now, as we start to go through each of these different ecosystems and these different flows, there are actually different ways to manage the cloud. And I'm not going to call you out if you're still doing it, but if you're take anything away from my part of the demo today, please, hopefully that you will no longer manage your cloud via the web console, because it's really difficult to scale. It's very difficult to maintain sort of exactly the same configurations between things. It's, you know, it's click, 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 hope for the best, and I'll make sure that that's there. And it tends to be that it's smaller cloud deployments that actually still do it this way. But it's really important to say that even if you have a small cloud deployment, you can still take advantage of everything that we're talking about today, and be able to understand and put these practices in place to make sure that you can scale and that your infrastructure can grow as it needs to. Excuse me. Then you have people who are taking advantage of like handwritten scripts, handwritten bash files, you know, maybe some templated YAML, and you know, you're talking into maybe, you know, CloudFormation templates, you know, ARM templates for Azure, Cloud Deployment Manager for GCP, lots of different things. And you've got to almost create your own tooling across the top of this, because, you know, YAML and JSON are not really human readable. They're not really human dealable these days. And there's a lot of very good tools that you can actually build in order to actually pump out these templates to make life easier. The nice thing about these is they can be automated, they can be versioned. You know, it's you can redeploy, but of course it's still, updates are a wee bit hard because you're at the mercy of taking this huge ream of YAML files and throwing it into the cloud. And then you've got people who have gone right to, you know, understanding that infrastructure is actually just as important as the software itself. Because, like, let's be totally honest, if you're an infrastructure developer, without your infrastructure, software cannot exist in the wild. Okay, this is why tooling like Snyk exists. This is why tooling like CircleCI exists. These are the infrastructure tools that are actually there in place that allow you to accelerate the deployment and delivery of your system. So understanding that code is a real way of doing this is actually something that's really important for people to see. Now, as both of Tomas and Angel actually talked about, is that, you know, DevOps is transforming everything that we do, not just in the terms of how we deliver our code or what we're writing or what we're doing, but also, you know, the ability to bring security into the mix, the ability to bring operations into the mix. It used to be the case of operations were the gatekeepers for everything. Operations were the people that actually had to be the sanity within an organization that stopped these applications going out into the wild that could effectively be broken or could effectively create security concerns. But the advent of cloud native and each team running its own system means that, you know, this centralized ops model didn't really work anymore. You had, instead of one application team and one ops team working closely together and throwing packages across the wall to the ops team to deploy and check, you're now talking that you could have 20, maybe 30, maybe 40 application teams, and actually then still a centralized ops team who took care of like your data centers and all your configuration management, but it was almost impossible to scale. So now we at Pulumi start to see that ops are becoming the enablers here. Ops are becoming the people who are driving forward because they don't want to be doing things manually. They don't want to be doing things, you know, being this gatekeeper of what's happening. They don't want to be the people on call, but the ops team can be that central point that talk to both the application teams and the security teams to make sure that things are done in the correct manner. You know, even though I say DevOps here, we're definitely sort of getting into the DevSecOps sort of world, because we believe that all of these teams should actually work together. And at Pulumi, we're actually trying to reimagine how this works, and we're actually calling this cloud engineering. Okay, but because without all of these different teams working together, you can't really take advantage of pushing your systems into the cloud and understanding what's going on in the cloud and taking advantage of all this vendoring and all these like amazing tools that exist today. So cloud engineer is a huge thing for us as we're going forward. But it's really important to talk about like one small concept. So we've talked about continuous integration. We've heard a lot about continuous delivery and security scanning. And then we heard some things about infrastructure as code. So just to make sure that I'm on the same level as everyone else about infrastructure as code, I want to just talk very briefly what it is. So it's bringing the best practices to infrastructure management. Okay, so providing that ability to collaborate on what's going on because it's actually codified. It can be checked in the source control, which means that we can track changes from your code commit the whole way through to deployment. Now, it's really important to say that what we actually want to do now is we want to create the ability that you don't have to have different teams all needing to use different variations of different languages and different toolings, what's going on. We want to be able to give people this single pane of glass, this single style application, and be able to create their infrastructure in the tooling that works for them. So like at Pulumi, we have built a tool that allows you to write code in languages. So it currently supports the JavaScript, TypeScript, Go, Python, and the .NET ecosystem. And it allows different teams within the same organization to be able to write code using the same tool, targeting the same platform, but with different languages. It works with any cloud because we have a plugin model for our providers. And it also means that each developer or each infrastructure developer or whatever your job role is in your organization, you can use the tooling that you use on a day-to-day basis. That's your IDEs, that's your testing tools, that's your linters. That's all of the normal workflow that you actually have to on top of. Now, this for us, Pulumi, we actually say that this enables this cloud engineering workflow. So as I say, your modern languages, you're creating of your code using your favorite tools, your IDEs. You can start to create layers of abstraction in the same way as you can with software development. You can share and create APIs. Those APIs can be tested. Those APIs can be mocked. All these different things can happen. You have a CLI tool, which will allow the embedding into that workflow, that pipeline that we're talking about. And of course, to be able to integrate other tools in there as part of what's going on. And then lastly, of course, we get the audit trail because it's infrastructure as code, and we get to understand all of these different things that are going on. I said it's any cloud, any language. And it's not strictly any language, but this is a plugin model that will allow you to create your own SDKs in your own language if you so wish, if you don't follow the 7 languages that we currently support. But we do actually have a lot of integration with a lot of clouds, a lot of SaaS products, and more importantly for developers themselves, it's real packages, it's using the packaging ecosystem. It can integrate with NPM, PyPI, NuGet. It has all of the tooling integration, all your IDE integrations, and works quite well with all these things together. So we actually think that this actually allows us to deliver code faster because we are creating this sharing, this reuse, this embedding into CI/CD pipelines. We can deploy much more confidently because we are language-based. We are able to take advantage of the language ecosystem itself, which means we can take advantage of the testing within that language ecosystem. And of course, as part of what we're going to demonstrate, that we can actually operate securely because we can enforce as part of our CI pipelines that security is embedded in what's happening. And then for us, it means it's much easier to scale because it's just simple code changes. It's a GitOps pull request style model that you can actually change your infrastructure, and that actually works really fast, really easy. Allows you to roll forward, also roll back if there's any problems, and understand what's going on in your system. So I'm going to hand it back to Angel right now, so we can start talking about a demo.
Yeah, so thanks for that, Tomas and Paul. Yeah, really interesting concepts there that I've been in this industry for a very long time, and I remember, being the lowly developer and getting my, completing my job, pushing, packaging things up, sending it over to ops, and then they come back with a slew of log files and reasons why my application was not functioning on their target environments, as well as maybe some security scans that were taken. And those took literally, I would package things up and it could be anywhere from 2 weeks to a month, 30 days later with all those results. And then I'm expected to fix that, right? Now, that's not obviously happening in today's environment due to the awesome tools like Snyk and Pulumi, as well as CircleCI, right? We're speeding that process up. So let's jump into a quick demo. see if I can find that here. Yeah, okay, great. So this, what you're looking at is the CircleCI dashboard. And this is a project we've all kind of been working on to illustrate and show what it is that we're talking about as far as CI/CD, security scanning, DevSecOps, and then also Pulumi's infrastructure as code. So what I want to show first is how you kick off a pipeline, which is pretty simple. I'm going to change some code. I have a project here that lives in GitHub. But basically what I'm showing you is just a quick, JavaScript application. It's just a static web page. But what I'm going to do is just a simple update, right? Let's say, yeah, we made some changes and now we're going to change this to version 2. Again, this is just to make some changes so that we can trigger our pipeline. Once that's there, I can go ahead and I'll just do it here inside of, and I'll say, let's say a commit message updated version 2, and then we'll commit that or stage that. Then we're going to commit this. So what I'm going to do now is just git push this change right up to GitHub. And from there, we should be able to see that once my changes hit GitHub for this project, it's CircleCI detected the changes, and now it's going to run my CI/CD pipeline. And in this pipeline, I'll just drill into it real quickly. What we're going to do here is a few things. We're going to create environments where we can run unit tests. We're also going to do a static scan of the application using Snyk, and as well as using Snyk to I'm going to build a Docker image based off of the application. And I'm also going to use Snyk to scan that Docker image. So while this is happening, let me just jump back over to the code and show you what that looks like in the CircleCI configuration.yaml file. So this is where my pipeline is defined. I have all the jobs here, right? So the first thing I want to show you is the orbs. What I've done here is this is basically an include statement. As I mentioned, we have orbs sitting in a registry online, and we have our partners Snyk and Pulumi. We're using their products in our pipelines, and this is how you can easily implement these things. I also wanted to show you real quickly that, right, this is the job that you're seeing running right now, the unit test. If I click into it, which is passed, you can see, right, like all that stuff, run unit tests, upload test results, and these are all, right, install dependencies, run unit tests. This is the command, right? I'm automating these things that you would do locally in your machines. And I wanted to also just like let Tomas kind of talk to these two jobs real quickly, which is basically scan the application using Snyk.
Absolutely, thank you, Angel. So as Angel alluded to earlier,
I'm sorry, go back one. Okay, good. Sorry about that.
What the orbs do, the Snyk orb in particular, similar to the Pulumi, it's reusable configurations to simplify adding tools into your pipeline so you can run them within the workflows. So what we're doing here, Angel mentioned we have 2 separate invocations of the Snyk orb. The first one is scanning the application files itself. So this is looking for issues in the open source components that the application is using. You'll notice at the very bottom of the section that Angel highlighted, you have the option to fail the build or to halt the pipeline in case you encounter issues. And you also have the ability to upload a snapshot of those results to the Snyk UI if you want to continuously monitor for vulnerabilities. In this case, what we're doing is just testing it on the spot in the pipeline, and we'll be able to see the results of that in the CircleCI section for running the Snyk test. So this is the same Snyk CLI that's available for download, and it presents upgrade guidance as the result of the Snyk scan. In this case, there are vulnerabilities in this particular package that we're using. And the second one is doing that exact same workflow, but this time for the container. And what we're doing is we're presenting those results in context of the container image. So while the first invocation scans for issues with the open source dependencies, the second one, what it's doing is it's scanning for issues in the container base image, which then will tell you if any of the Linux packages used by that image have vulnerabilities. Similar to the one up top, we can choose to halt the pipeline in case we run into issues. And what the Docker scan will also do as a result of the Snyk test, when you pass the Docker file to it, will actually also be able to recommend, you see it there at the bottom, alternate base images that you could use, or your developers could use, when building their container images if they want to use a slightly more secure base image. So we present this information, just like developers can act on the open source remediation guidance, they can act on the container remediation guidance as well. So that's a little bit of what's happening during the Snyk stages.
Yeah, and that's like, again, really interesting that, you know, we can easily implement that functionality. And by the way, like, you know, it's really cool that developers are able now to kind of be semi involved in the security process, and it also alleviates the pain for your security officers to be super involved in what the developers are up to, right? So it kind of gives that if you can shift all that stuff left, like we did in our example here in our pipeline, that again frees people up, right? And as you can see here, we've done things concurrently, right? So with the CI/CD pipeline, you don't always have to do things sequentially. When you see this kind of stack of things happening at the same time, that means they're running in parallel or concurrent, and that speeds things up a hell of a lot faster, right? Than having to wait, like what you see here, a dependency. So obviously we need to build a Docker image and have it ready and available before we can deploy to Kubernetes, which is what we're doing here in this bit here, which is, if I drill into it, we're using Pulumi, as you can see, right, to create a Kubernetes cluster in GCP so that we can then deploy this newly released version of code to a target environment, so that then we can even do more testing on it in its the environment that we're targeting for deployment, right? So let's say this is going directly into production. Most of the time I see folks just deploy it and then they leverage a monitoring tool later on to kind of, test it. Now that's a production type direct release to production kind of on demand process. Generally speaking, most people operate a different way where they're deploying to like staging or some other QA environment. This will help you with a pipeline like that, right? You'll be able to kind of say, all right, I'm not ready to release this to production, but I want to test in the environment like Kubernetes. That's like we're doing here. We're deploying to Kubernetes, and then we could run a few tests after it's deployed. And then you could shut all that infrastructure down. So I'm going to let Paul talk about, let's jump back over to, I'll let Paul talk about the Pulumi aspects of this, which is, if we're looking at the pipeline, is the deployed to GCP job here. I'm just trying to, there you go. So Paul, please talk about what's going on here.
So Pulumi is a desired state of your infrastructure. So it's actually very declarative. Angel, could you just swap to the actual Pulumi code itself, please? So what we actually have is we have in this specific case, I have this written in TypeScript, and you'll see that as we follow down, we actually get all of the, the proper IDE sort of feedback that we would actually require. So the first thing that we do is we actually set some defaults that unless the SHA-1 of the new image is actually set as an environment, what we do is we always grab the latest as part of our deployment just to see what's going on in here. We set some constants around the Docker image, and then we can, of course, do string concatenation around that. The same for the machine type. Then we actually go off to GCP and we get the latest version of Kubernetes that's actually available to us. So rather than always being stuck in an old version, or something that's maybe not supported, we can actually make requests to GCP to get a version back. Now, of course, you would not want to do this in production because it could always change your infrastructure every single time. You're at the mercy of the cloud provider here. So you would choose a suitable sort of thought process around this. Then we would declare a GKE cluster. It will have 3 nodes in it. It'll have that specific version, and we can give it some specific node config and some OAuth scopes. So as you can see, it's quite easy, even though it's written in code, And when I say code is written in TypeScript, it's quite actually easy to actually follow what's going on here. Then we get into, we can build the kube config. So Pulumi has this idea of, it's a promise-based system. So, and what it does is it will resolve those promises as part of the application flow. It's declarative, but it's an imperative application, so it works top to bottom, and it will be able to create these dependencies between what's going on. So as we created the cluster, we get some level of information back from the cluster, which will allow us to derive the kube config. We can inject a Kubernetes provider into our application at that point, and then we can actually target deployments of resources to that cluster. So here we have a namespace. Then after the namespace, we have a deployment. The deployment will actually be the spec for our Docker container that's been built in the previous step. It will have 3 replicas of that available. It will open up port 8080, so the load balancer will effectively talk to the container port on 8080, and then we'll create the service that actually allows you to expose this to the outside world. So, you know, not only have we been able to scan the container, we've actually been able to build the container, push it up to the registry. We've then been able to take that container, deploy it into Kubernetes setup, much like we would in production or any other environment. And then we get an endpoint from the back of it that we can use in order to test. And if you can go back to the pipeline, that'd be really cool. And you'll see actually as part of the pipeline right here, you'll see the Pulumi update has actually passed. So at this point, if we will have a fully working Kubernetes deployment, and right at the bottom we'll get an endpoint. And if you can take that endpoint and you can push that into the browser, and we will actually see the version of our application that has been deployed. And the version number in that application should match what Angel pushed in earlier, which was, there you go, 002. And of course, if we bump the pipeline the whole way through, that would then upload version 3 and so on. And then the last part of the pipeline that's actually happening here is that we're verifying the application deployment. So we're making a request to the endpoint. Of course, this is just using, this is actually broken, but that's okay. So what it would actually be doing
it ran
is effectively
the job.
yeah, it would be making a curl command to the endpoint, checking that we got a 200, checking that, you know, the application was working, it was accessible to the end user, and that it was, you know, working and warmed up as expected rather than throwing a 404, and then the pipeline would continue. So it's great to be able to show that Pulumi works really closely in embedding this as part of the pipeline.
Angel, I can't hear you.
Okay, so yeah, I just wanted to say that this job here is just, again, to verify that the application is running after deployment. Obviously, it's running because we have this. The test failed, right? So I need to look at that, but that's okay, right? That's software development. This is keeping it real, I guess, right? But the other thing I wanted to kind of show off here is we do have the cluster running in GKE, right? Here's the workloads. You can see that we have 3 pods running. All within that's that same application running within Kubernetes. We also have the ingress, right? So like all these things were built using the code from Pulumi, which is awesome, right? And if you need to make any changes, you're doing it here. The other thing I wanted to address is, like, let's say right now I have a manual step. So in CircleCI, you can like create like these manual steps within your workflows. Normally I would have this verify and then destroy it all automatically, right? So you don't want to leave this architecture or this infrastructure standing up, you know, consuming dollars and money and resources. So you would just test it, verify everything's cool, and then destroy it all, which I'm going to do here with a click of a button. This is an approval job, so like there's going to be jobs where maybe managers or some people that are responsible for certain things need to you know, review and then allow your pipeline to continue on processing. And that's what I just did, was approve the destruction of this cluster. And what happens here is Pulumi's, you know, instantiated again, and then the destroy command is submitted. So basically, right, it's from start to finish, we're doing all the things that we need to ensure that this application is as reliable as possible, and the quality's there, right? So the release is going to be pretty much, I would say, with a nice seal of approval, or at least as much as possible, right, as best you can. So that's basically the demo. The infrastructure is going to be destroyed. And yeah, let me jump back over to some Q&A.
Great. So anyone who has questions, feel free to drop them in the chat. We have had a few coming in, but there's a little bit of time here still for some more. Let's see. One of the questions, do we really need to scan every change to code every time? And isn't this overkill? So I don't know, Angel, do you want to take that one, or?
Yeah, I can do that, sure. So the answer is, it depends, depending on like, there's a couple aspects, right? So you're scanning code because you want to make sure that every release you run is right, pretty compliant with the security standards. Now, there may be some exceptions to your security policies, which that could come from any number of people, but I'm assuming it's going to come from some sort of security office that's responsible for this stuff. But as far as pipelining goes, as if you're in development stages, I would say have it run at least once. But you can also be creative and configure your pipeline configuration to filter out certain things. So like, let's say you're just developing and you're trying to build up some new functionality. You don't really need to scan at this point, and you want to speed things up. You can create filtered triggers. So you can add a tag that will block the certain jobs from running, so to speak, right? So the answer is it depends. But if you want to go faster and then implement that a little bit later, you can implement filtering, which will enable you to do like selective runs of jobs.
Great, and this one might be for you, Tomas. Can the sneak or break the pipeline in case of vulnerabilities?
Yeah, absolutely. There is a stanza within the CircleCI config file where you can choose severity of vulnerabilities that will return a different exit code than 0. So you can tell Snyk, hey, if there's any high severity vulnerabilities in this code change, halt the pipeline. Or you can tell Snyk if there's any vulnerabilities that can be remediated with a component upgrade, break the pipeline. So the short answer is yes, there are multiple ways that you can implement ops-centric gates using the Snyk circle code.
And changing this fail on issues flag to true will do that. It will block, will at least fail that particular job. So right, if you wanted to do that, it's very easy. It's just a flag inside of the orb itself.
Yeah, thank you for showing that, Angel.
No worries.
Great, maybe one more. How can we debug pipelines in the execution runtime?
Oh, great. Yeah, so we at CircleCI have a feature called rerunning jobs with SSH. I could show you that real quickly. So let's say, I don't know, I want to rerun this destroy. I'm having issues with my destroy job, which is actually, it's still running, but or it was running. But basically, you would just rerun this job with SSH. All of this will occur again, right? So it'll replay that particular job. And if you have this is more useful in the failed sense, but you could still run it right in a past job or a green job. But basically, what's going to happen is once this finishes running and your job fails again, the executor or the runtime that this ran in, which is a Docker container, will stay alive and will give you an SSH, all the SSH details that you can use to then SSH into that runtime and debug in real time, right? So this is a very kind of unique feature to CircleCI. Not a lot of tools have this, but it's a very useful one that I know I myself appreciate as a developer because you get that self-serve, quick ability to debug instead of having, again, to bother maybe an ops person or involve anyone else that really, you're going to be waiting on folks. And the idea here is to just keep going, fix your code, and move on to the next task.
That's so important, Angel. I'm glad you mentioned that, because due to the ephemeral nature of containers, it is very hard to troubleshoot sometimes why something failed if the instance just dies immediately. So yeah, that's really.
Well, I call that debugging in the blind, right? Like when you're just left with log files and what happened, and then you have to recreate that environment inside of your development environment, which is, again, is usually a laptop or some disparate server somewhere, right? It's not connected to anything you're running. You definitely, right, can appreciate having the ability to go into that runtime where it failed and the environment where it failed and do all of that forensics to help out debug the problem a lot faster, for sure.
Great. Well, thank you to our guests and our speakers here today, and to everyone who joined us. We'll be sure to send the recording following this, and we look forward to seeing you at the next Snyk webinar. Thank you.
Thank you, everyone.
Thank you.